Welcome back. In this video, we are going to use some of our previous knowledge to expand our learning on trigonometry. So we're still working with Introduction to Trigonometric Functions, but we will still need to use our knowledge of the Pythagorean theorem, our Pythagorean triples, our special right triangles, and the distance formula, plus SOH CAH TOA, all converge here in trig. So make sure you're familiar with your triples, the 3, 4, 5, the 5, 12, 13, 7, 24, 25, and 8, 15, 17, and of course all their expanded forms. So 3, 4, 5 is the same as the 6, 8, 10, and so on. And of course your special right triangles. So the 1, 1, square root of 2 is the 45, 45, 90, and of course your 30, 60, 90, which is x radical 3, and 2x, or 1 square root of 3 and 2. And of course, we'll also use the distance formula. We're going to use that quite a bit here. That's our Pythagorean theorem in disguise, where d equals the change in x squared plus the change in y squared. And of course, if we're centered at the origin, at 0, 0, the distance formula becomes pretty straightforward. It's just d equals x squared plus y squared, the square root of x squared plus y squared. But in this unit, and as we continue in trig, the distance formula, we're not going to use d anymore, but r. And r will represent the hypotenuse of the right triangle, as the distance formula always does, represent the hypotenuse of the right triangle. But we'll call it r equals, and then the square root of x squared plus y squared. To show you what I mean, let's take a look at the Cartesian plane here, and let's go ahead and plot the point, say 4 on the x and 3 on the y. So 4 on the x, we're going to go out 4 units on the x-axis, and we're going to climb 3 units high on the y-axis. And from that, we can form a right triangle. And our right triangle will always have the right angle will be on the x-axis, and our hypotenuse of our right triangle will extend from the origin. So our distance r is from the origin out to our point. And then, so here is our right triangle with our right angle on the x-axis. Our right angle is not where the x and y-axis meet. It's here on the x-axis. Well, as you can see, we've got a right triangle, but our height, of course, is our y, and our length along the x-axis is x. And this will work no matter what quadrant we're in. So if I'm in the second quadrant, and let's just say I choose the point -5, 2. So I'm -5 on the x and 2 on the y. That my r is going to extend out from my hypotenuse, will extend from the origin. I can draw a line straight down to my x-axis to form my right angle. And of course, I've gone -5 units from the origin and 2 units high above. So I've got a right triangle here with 5 and 2. And then we could easily calculate r using our distance formula. So looking at our right triangles here, let's take a look at the first one from the point 4, 3. Our reference angle then becomes this angle from our initial side out to r, our hypotenuse. Okay, so our reference angle in the second quadrant from the x-axis to r. Okay, so this is going to be our angle theta. So our reference angle then with our trig function, if this is our reference angle, the one from the origin, The sine we know is opposite over hypotenuse from what we knew about SOH CAH TOA. Well, the opposite of our reference angle, the opposite side, will always be y, and our hypotenuse will always be r. Same here in the second quadrant, and that'll work in the third quadrant and the fourth quadrant as well. So from theta, opposite side is y, and the adjacent is x, and our hypotenuse is r. So then the cosine we know is adjacent over hypotenuse. Well, it's also going to be x over r. And then tangent will be y over x, opposite over adjacent. And then, of course, we have our reciprocal functions. So the reciprocal of sine is cosecant. So that would be hypotenuse over opposite. So that would become r over y. In the secant, hypotenuse over adjacent, r over x. The cotangent, adjacent over opposite, or x over y. And one of the things I use to memorize this is it's really in alphabetical order. Okay, cosine comes before sine, c comes before s in the alphabet, and x comes before y. So sine is y over r, cosine x over r, and then tangent, opposite over adjacent, is y over x. So we can use our alphabet to help us out. And then the reciprocals, well, then you'll have to flip those. And also notice that no matter where r is, r will always be positive because distance is positive. Okay? So while the terminal side of the angle might be in, say, the first quadrant, x and y are both positive, and so is r. So in the first quadrant, remember our ordered pairs, x and y, are positive, positive. In the second quadrant, our ordered pair is x, y, but x's in the second quadrant are negative, y's are positive. So this is going to be important for sine and cosine and tangent, because remember, sine is y over r, okay? Or cosine is x over r. So if x is negative, if we're in the second quadrant, that would make sine or cosine negative, depending on where you're working. And we'll do some samples. In the third quadrant, our ordered pair still is x and y, but x's are negative and y's are negative in the third quadrant. And in the fourth quadrant, x's are positive and y's are negative. So it's going to be important to know when you plot your point which quadrant you're in, if x is negative, positive, and if y is negative or positive. So let's take a look at some sample problems. The terminal side of an angle theta is in standard position and passes through 8, -6. Find the values of the 6 trigonometric functions of theta. So we want to first draw a diagram of the angle in standard position. So we're going to plot 8, -6, and we're going to draw r. And then we're also going to mark our angle theta. So 8, -6, 8 on the x. It's going to be out here somewhere. And -6 on the y. Might be down there somewhere. So 8, -6 is here. And I'm going to start by drawing r. Okay. So there's my hypotenuse. It extends from the origin out to my point. Okay, and now I've got my right triangle, and my reference angle theta is here. So I'm working down here in the fourth quadrant, and my y's are negative, and my x's are positive. And we might see the common factor here, 8 and -6. They are reducible by 2. We can factor out a 2, and we have really 4 and 3. So let's go ahead and calculate r. R is equal to x squared, which is 8. And you might use 4. And y squared is -6, and you might use -3. So r equals square root of 64 plus 36, or r equals the square root of 100. R equals 10. You may recognize this. You may have recognized that was a 3, 4, 5. So we're going to do our trig ratios. Well, we're going to go ahead and reduce what we have. So let's take a look. So x, really, we can use 4. Y, we can use -3. And r, we can use 5, because this is a 3, 4, 5. So then the sine of theta, which is y over r, becomes -3 over 5. And the cosine of theta, which is x over r, equals 4 over 5. And the tangent of theta, which is y over x, is -3 over 4. And then you can do your reciprocal functions right away as well. So the cosecant, which is r over y, 5 over -3. The secant of theta is r over x, or 5 over 4. And our cotangent of theta is x over y, or 4 over -3. So it will be important to identify x, y, and r. You should do that for every problem like this. Now, let's suppose that our point xy is in a given quadrant. Decide whether the given ratio is positive or negative. So they're saying we're working in quadrant 3. So the question is, we're in quadrant 3. So if we're in the third quadrant, we should know that x's are negative and y's are negative. So that must mean r over y is positive over negative. Our ratio here is negative. In quadrant 4, the fourth quadrant, x's are positive, y's are negative. So if our ratio is y over x, that would be a positive, would be a negative over a positive, which is also negative. Let's take a look at our third sample problem. Here, the terminal side of an angle theta is in standard position, and it passes through -1 square root of 3. Find the 6 trigonometric functions of theta. Well, I will get you started on this one. So we'll draw our Cartesian plane, -1 on the x, square root of 3 on the y. So square root of 3 is a little bit less than 2, so our point's going to be up here, -1 radical 3. So I will go ahead and we want to draw R and finish our right triangle. So we are square root of 3 high. We're -1 along the x-axis. So we can calculate R. R is equal to our x squared, which is -1 squared, plus the square root of 3 squared. So we simplify. We get 1 plus 3. So r equals the square root of 4. R equals 2. So our hypotenuse is 2. Our x side is negative 1. Our y side square root of 3. Hopefully you see that this is a 30, 60, 90. Our angle theta in this problem is the 60-degree angle. But we need to calculate our trig functions. So it looks like x is negative 1, y is square root of 3, and r is 2. So we know the three sides. So I'm going to leave finding those 6 trig functions up to you. So bring those answers, and I will see you in class.